Hello, in this tutorial we are looking at the concept of algebraic expressions. So by the end of this video, we should be able to understand what algebraic expressions are. You should be able to identify algebraic expressions. You should be able to simplify algebraic expressions, and you should be able to solve problems involving algebraic expressions. My name is Ademola Folarin. This tutorial is powered by IOTA Virtual Learning. So let's start. What do we call algebraic expressions? An expression in a set of terms in which letters and numbers are mixed together using addition, subtraction, multiplication, or division is what we call algebraic expressions. We are familiar with situations where we have statements such as 2x plus 3 minus 5x plus 2y. This is an algebraic expression. We may even have it in form of fraction, such as x plus y over 2 minus 3x over y. This is an algebraic expression. So, an expression in which we have letters combined with numbers using addition, subtraction, multiplication, and division or division. So that is what we call an algebraic expression. Algebraic expressions express numbers using letters or alphabets without specifying their values. So we are familiar with things like this in mathematics. That is what we call algebraic expression. Let's try to look at some problems in algebraic expressions. Looking at this, we are asked to simplify this expression. To do this, we first look at the denominator. The denominators, the LCM of y and 2y. If we look for the LCM of y and 2y, it's going to be 2y. Or better still, since this one involves y, this also involves y, we can multiply both terms by the highest denominator, which is 2y. So if we multiply both terms by the highest denominator, which is 2y, that means 2y is being multiplied by 2x plus 1 over y minus, we also have 3x plus 2 divided by 2y if we multiply by 2y. So at the end of it, we realize that this can cancel out this. This is 2y. If you say y cancel out. So now that we have that, it becomes y open bracket 2x plus 1 close bracket minus 3x plus 2. So the next thing for us is to open the bracket. This becomes 2xy plus y minus 3x plus 2. Then we put similar terms closer to each other. So we can say 2xy minus 3x plus y plus 2. So we've been able to solve this, simplify this algebraic expression. So we may as well have something where they will ask us to simplify expressions such as another one. Let's say we have 5 divided by x minus y equals, 5 divided minus, if we have 4y minus x. If our aim is to simplify this, the very first thing that we do here is to find the LCM of this denominator. Since it is not numbers, they are not numbers, so we can say the LCM of these. This becomes, let's just take the two denominators, that's x minus y, y minus x. That means x minus y goes here, it will be y minus x. That y minus x multiplied by 5, that will be 5 open bracket y minus x minus, then y minus x goes here, we have x minus y, multiply it by 4, that will be 4 open bracket x minus y. Then we can say, open the bracket at the top there, we have 5y minus 5x. Use this negative 4 to open this bracket. That will be negative 4x plus 4y. Everything over what we have here, which is x minus y, y minus x. Now that we have that, we can further simplify this. This now can be 5y plus 4y. Here that we have minus 5x minus 4x, still divided by x minus y, y minus x. So if we take this further, we can make it become 9y minus 9x divided by x minus y, y minus x. Now that we already know this, this can become, you factorize. 9 is common here. That means we can let it become this. 9 open bracket y minus x divided by x minus y, y minus x. Now that we have this, let's compare the numerator and the denominator. We have y minus x here, we have y minus x here, so we can cancel out this. Then we simplify the given expression to 9 divided by x minus y. And by this, we've been able to simplify the given expression. Isn't that interesting? Yes, it is. So let's look at another problem under this algebraic expression. Looking at this now, I bet we can now approach this ourselves. We want to simplify this concept. So to simplify this, the very first thing, we have the denominator here as 3 and we have the denominator here as 5. If you look for the LCM of 3 and 5, that will be 15, right? Oh, fantastic. So can we multiply that 15 by both terms? That will become 15 multiplied by 2x minus 3 divided by 3 plus x minus 1 over 5 multiplied by 15. So here we can say 3 goes here 1, 3 goes here 5, 5 goes here 1, 5 goes here 3. Then we can turn it to 5 multiplied by what we have here, which is 2x minus 3 plus this one, 3 multiplied by x minus 1, close the bracket. Then we open the bracket. It becomes 10x minus 15 plus 3x minus 3. So the next thing is to pack the terms involving x together. 10x, bring this, plus 3x minus 15 minus 3. So this can become 13x minus 18. So we've been able to simplify this algebraic expression. So when we say algebraic expressions, they are expressions in which letters, numbers are combined together. They may be in form of fraction, they may be separate. So mostly the steps of solving them involve we factorize, we simplify them. Sometimes it may involve we expanding them. Isn't that interesting? So let's look at a situation where we have it in word problem. Most of the time when we are given word problem, it often leads to algebraic equation. So let's look at this. Here we have a WAEC question year 2020 saying 5 years ago, Musa was twice as old as Sisi. If the sum of their ages is 100, find Sisi's present age. We can say let their present age, just pick the initial of their name, let their present age, okay, let Musa's present age, Musa's age equals M, right? Sisi's age equals S. So now let's interpret it sentence by sentence. 5 years ago, Musa was twice as old as Sisi. If Musa's present age is M, that means 5 years ago, Musa's age will be M minus 5, right? So it was twice as old as Sisi's age. That will be equals to 2 times Sisi's age 5 years ago will also be S minus 5, because that is 5 years ago. So let's try to look at this. That will become M minus 5 equals 2S minus 10. We can pin this one down. Then the next part says, if the sum of their ages, if the sum of their ages is 100, sum of their ages is 100. That means is 100 is a present age we are talking about here. So the present age m plus s is equals to 100. Find Cisse's present age. We are looking for s. So to look at that, from this part now, can we make Musa's age the formula? It becomes m equals 100 minus s. So here we can now put the value of m here into this. Putting the value of m into this, that becomes 100 minus s, that's for m here, minus 5 equals 2s minus 10. So if we then try to solve it further, this becomes 100 minus s minus 5 equals 2s minus 10. Now let's do something, collect like terms. That will be 100 minus 5. This is also a similar term. That will be plus 10 equals 2s plus s. So when we look at this, this becomes 95 plus this. That's 105 equals to 3s. So divide both sides by 3. That will be 105 divided by 3 equals s. Fantastic. So 3 goes in 10. 3, remainder 1. Then 3 goes in 15. 5, remainder 0. That's s. So we can then say Cisse's present age is therefore 35 years. That is, Cisse's present age equals 35 years. Let's try to look at it if truly we are right. If Cisse's present age is 35, that means Musa's age is 65. So 5 years ago, let's remove 5 from each of it. 5 years ago, Musa will be 60 years. Musa was 60 years. Cisse was 30 years. Indeed, Musa was twice as old as Cisse 5 years ago, because Musa was 60 years and Cisse was 30 years. So these are ways we solve algebraic expressions. If you enjoy this, don't forget to like this page and as well subscribe to our channel for more educational videos like this. Thank you.